Much like is the case for hypothesis tests, for confidence intervals also, it's okay to think of your interval as an interval to represent mu sub d, a single parameter, or as an interval to represent a difference of two means, even though the techniques that we're applying to find it all have to do with a single quantitative variable and a single mean. So just like we said for hypothesis tests, this is preferred for a matched pairs study because it's staying consistent with how we handle our data, but this is not incorrect. And this is what we would do if we had two independent samples. So mu sub d preferred for matched pairs. Mu1 minus 2 minus mu2 does work for both, as long as if you have a matched pair study, you'll still do the analysis in terms of one quantitative variable. So again, we take the formulas we had for one quantitative variable or for one mean, and we adapt them to a single variable that represents the differences. Both of these are the same formulas that we saw for one mean, but with a sub d written in. And therefore, the margin of error of our confidence interval is t star times s sub d over square root of n. The sample statistic that we use to start our estimate is x bar sub d. And t star is still a critical value of the t density curve with n minus 1 degrees of freedom. So we'll use a t-distribution to find a 95% confidence interval for the mean difference in prices Jacos minus other. We'll need to refer to summary statistics on the previous page for this. And the three values we're going to end up using I've written over here. X bar sub d is 115, s sub d is 124.833, and n is equal to 10. So let's find our margin of error. The margin of error is going to be t star times the standard error, where the standard error is s sub d over square root of n. So my standard error is 124.833 divided by the square root of 10, which comes out to be 39.476 if I round it to 3 decimal places. So my t star I need to get from table A. I have 9 degrees of freedom and I want a 95% confidence interval. So here's my 95% and here's my 9 degrees of freedom row. Looks like 2.262. And therefore my margin of error is 2.262 times the standard error 39.476. I get 89.3. I chose to round this to just 1 decimal place because I see that my estimate is rounded to the nearest whole number, so I don't want to go much past. I only go to the same number of decimal places as my estimate, or maybe 1 decimal place further, so that my confidence interval is x bar sub d plus or minus that margin of error, which is 115 plus or minus 89.3. Subtracting gets me my lower bound of 25.7, and adding gets me my upper bound of 204.3. And this is a 95% confidence interval for mu sub d. We notice that the two endpoints are both positive, meaning that in our whole confidence interval, we believe that the mean is higher at Jacos' garage than at the other garage, And that's consistent with what we found in our hypothesis test, although because our hypothesis test was one-sided and confidence intervals are more of two-sided thinking, sometimes if it's really close, they don't come out perfectly consistent. Now we want to interpret this, though, and say that it looks like Jocko's is charging, on average, about $25 to $200 more for cars with similar damage than the other garages. So here's my statement, my interpretation of the confidence interval. With 95% confidence, estimates from Jocko's are on average $25.70 to $204.30, higher than estimates from the other garage. It seems that it was probably one other garage that we're comparing this to, so we'll just state that in the singular. The things I want to make sure are present here. Of course the numbers, but no one ever really forgets to put the numbers in. Units. If my data are measured in dollars, then my means are also measured in dollars. Higher than, I want to make sure it's clear in whose side the favor comes out, right? I also need to make sure to have the word average in here because we are talking about a mean. And estimates in general rather than just these 10 estimates. So we're referring to the population, not to the data set. Not to the sample. It's important to make sure that our statement is not too vague. If the confidence interval is entirely positive or is entirely negative so that the favor is always in one direction, right? One is always higher than the other. We need to make it clear in our statement which one is higher. And just like with any confidence interval, we always have to indicate what parameter it represents. So a mean, an average, in some cases a proportion, a correlation, that sort of thing.